Hello, my name is Nathan Choi, and I'm thrilled to present our latest work in social navigation, Sean 2.0, Formalizing and Generating Social Situations for Robot Navigation. To enable the training, evaluation, and benchmarking of social navigation systems across different social contexts, we propose Sean 2.0. Sean 2.0 is a new simulator to help researchers fairly evaluate different social navigation policies. Prior work in social navigation considers only one or a few specific scenarios. For example, past work studied robot navigation in scenarios where a robot crossed a path along which people were moving, a robot approached users or groups of users, or moved through a crowd. Instead of focusing on one scenario at a time, could we build robot navigation systems that adapt to varied social contexts? Our prior work, Sean 1.0, was designed for training and evaluating social navigation algorithms. It supported integration with ROS and high-quality rendering of virtual pedestrians. However, it only provided simple waypoint navigation for the pedestrians, requiring time-consuming handcrafting of their behavior, and it had no notion of social context. For Sean 2.0, we took inspiration from work in psychology to describe navigation context based on social situations, which encompass the robot's task and behavior of nearby pedestrians within a physical environment. Sean 2.0 incorporates classifiers for identifying 5 social situations defined using formal logic, multiple methods of generating pedestrian behaviors, including the novel behavior graph approach, a number of important components such as vision and depth sensors, several physical environments, and different means of specifying robot tasks. Finally, Sean 2.0 has been totally redesigned from the ground up to implement a new, more user-friendly architecture and programming interface. In our first attempt at specifying pedestrian behaviors, we manually handcrafted the location for each pedestrian. We did this for 5 social situations using navigation waypoints or positions within conversational groups. Here is an example of a robot moving down a corridor. We expected handcrafted pedestrian behaviors, such as the one shown here, to allow the robot to experience the particular social situation for which the interaction was designed. Notice, though, how the pedestrian here interacts with the robot. Through the choice of waypoints, we intended the pedestrian to navigate from one end of the corridor to the other. However, we see the interaction between the robot and pedestrian causes the person to circle back around. This situation is no longer a typical case of the robot and pedestrian navigating down a path, but the pedestrian appears confused and is now in conflict with the robot. To identify when disconnects between an intended social situation and the actual social situation occur, we use the proposed logic-based definitions for 5 social situations relevant to navigation and implement them as classifiers in Sean 2.0. To reduce the time required to manually handcraft pedestrian behaviors and allow the robot to experience a range of different social situations in densely populated environments, we proposed the behavior graph, a novel method of specifying pedestrian behaviors based on a spatial graph annotation added to the physical environment. Adding graph nav annotations to any environment is straightforward. Simply drop in the Unity prefab object. The empty graph prefab contains a single node from which other nodes can be added. Edges are automatically attached. Pink nodes represent navigation waypoints, and blue nodes represent locations for conversational groups. Tools in the inspector pane can be used to add either type of node. Graph parameters, such as group size or number of agents spawned at a given waypoint, are available for modification in the inspector pane as well. Join 2 existing nodes together with a new edge by simply dropping one node onto the Create Connection field of another node in the hierarchy view. To make configuring Sean easier, we provide a custom user interface that's available in the inspector window after selecting the Sean object in the hierarchy view. To run the graph we've just created, simply select the graph scenario and any task and start the simulation by hitting play. Here, we see a top-down view of the simulation before the robot task begins, and when the robot task starts, the robots move to its start location. Our evaluation aimed to understand the influence of training and evaluating social navigation policies using different methods of pedestrian control. We evaluated 4 robot policies using typical metrics from the social navigation literature. Overall, policies perform better when trained on behavior graph data, and rollout scenarios with behavior graph data were more challenging than the alternatives. For example, we found that there were more intimate distance violations for policies rolled out in the scenarios with the behavior graph compared to scenarios utilizing random or handcrafted pedestrians. Dissecting the data by social situations, which we show here on the right side of the screen, we see that the increase in violations in the behavior graph rollout scenario occurred mainly in the cross-path and down-path social situations. This type of analysis suggests that performing data augmentation for a learned policy and adjusting the training data distribution to include more examples from the underperforming social situation could increase overall performance. We validated that our system was useful for users outside of our team as well. And to do this, we gathered user feedback from 4 researchers who were new to using Sean 2.0. Although one researcher noted that occasionally pedestrians exhibited unnatural behavior, in general, the feedback was broadly positive. For example, one person noted that the lab scene and the warehouse scene both looked good, and another researcher who was familiar with the dynamics of the Curie robot, one of the robots that we include in Sean 2.0, noted that the base dynamics were realistic and Curie followed the navigation path much in a way that looks similar to the real platform when controlled by the ROS navigation stack. One researcher who had prior experience with Sean 1.0 noticed that Sean 2.0 was definitely easier to navigate and more user-friendly in terms of getting started with the simulator. I hope that Sean 2.0 can be useful in your work. Please see the project website for the documentation, source code, and tutorials to help you get started.